So, basically in this lecture I want to focus on how the information that we have represented in the ER model, information about an enterprise database that we are trying to design, we will capture that in an ER model, which is a conceptual level model, into the relational model. We have just studied this relational data model, and we know that it gives certain concepts like relations, keys, foreign keys, and things like that. So, now we focus on how to translate or map the information that we represented in the ER model to the relational model. So, they give they in some sense are different representations of the real world enterprise, and now we were trying to get the relational scheme. Now, so the general approach that we will use is that for both entity types, right, entity types as well as the relation types, we basically map them into relations. Okay. So, notice that we have in the ER model context, we have these two concepts, the concept of an entity type and the concept of a relationship type, and of course, there are variations of this entity type like strong, weak and all that. Okay. But when it comes to relational data model, we have only one, the concept of a relation. So, basically for each entity set as well as a relationship set or type, right, entity type or relationship type, we interchangeably use these words. So, for each entity set and relationship set in the ER model, we will have a corresponding relational table. So, let me use this word table in this set of slides to kind of make it very clear that we are talking about relations. Now, the relation table with the same name as that relationship as the entity type or the relationship set. So, that is the basic approach, and then each of these tables will have multiple columns. So, kind of we are calling attributes as columns here, whose names are obtained from the attributes of the entity types or the relationship types. So, we will see the details as to how exactly we should obtain these names. Okay. So, let us first focus on strong entity sets. Okay. So, let us say there is a strong entity set EI. So, what we will do is to create a table TI for that particular entity type set. The name of the table will be the same as the name of the entity, but we in this case we are just representing it as symbols like EI, TI. Now, the entity set will have attributes, right. Now, it will have different kinds of attributes. So, we will take the simple attributes, and then if there are composite attributes, what we do basically here is to take the simple components of those composite attributes. Okay. Each of these composite attribute has components, right. So, and that component itself can be again composite, right. And so, we kind of go to the leaf level in some sense and pick up all the simple attributes, simple components of all these composite attributes, and those names alone will be the attribute names for the table TI. Okay. One thing that we have to do is to handle this multi-valued attributes of these entities separately, and I will talk about how to handle multi-valued attributes. Right now we will ignore the multi-valued attributes of the entity set EI. Okay. We will take the simple attributes and composite attributes. Okay. For composite attributes, what we will do is to pick up their simple components and then check whether they are simple or not, and then pick up that. Okay. So, basically you might also realize here that we are in some sense losing some information, like for example, while modeling a person, we might say that the name has two components, the last name and the first name. Okay. And these two things together are called name. That is how the model had as composite attribute. So, we will now basically ignore that name thing and then only take the L name, F name. If that is the name, those are the attributes, the names that are being used, then we will simply pick up L name and N name as the attributes of the table we are creating. And a little later we will see how exactly to handle multi-valued attributes of these entities. Now, we have to now decide the primary key for this table Ti. So, the primary key will be basically decided by picking up the primary key of the entity EI. So, whatever was the primary key attribute of the entity, and that would be an attribute of the table we have created, and so we will make that as the key here. Now, as we will see later, basically the primary key would be actually referred to by other tables via the foreign keys in order to capture relationships. Okay, we will see that. So, here relationship sets also are going to be translated into tables, and so we will see how exactly we will use foreign keys in order to capture that associations. Okay, so move on. Let us look at weak entity sets and weak entity sets. Recall that weak entity sets are basically entities that do not have an independent existence, and they kind of depend on some other entity for their relevance to the information system. So, we have weak entities. So, let us say some E prime is a weak entity owned by some strong entity E. It could even be owned by another weak entity, but we will take up that case a little later. So, let us say it is owned by a strong entity. So, this E prime is going to be converted into a table, say R prime, where we will we will have to make up the attributes for this E prime, the table. So, these attributes of R prime, the table, will be basically the attributes of the weak entity set E prime, and in addition the primary key attributes of the identifying strong entity or the owner entity. There is a owner, right, because E prime is a weak entity, it has a owner. So, pick up the primary key attributes of the owner and include that as attributes of R prime. Okay. Now, you can see that the attributes of attribute of E prime will have only what is called a partial key. Okay. And so, in order to distinguish between the various entities in the weak entity set, we need the information about the owner entity. So, the owner entity's information will come because we are including this primary key attributes of that thing. Okay. Now, let us look at this case. Suppose the owner is itself is a weak entity. in which case the partial key of that entity plus the primary key of the owner of that would be the attributes that we will include. Of course, this chain will go on because it has to end with some strong entity. Okay, so basically you can see that in case a weak entity is owned by another weak entity, then the approach we can follow is basically first map the owner weak entity into a table, okay, and then bother about mapping the weak entity. Okay, so that is how we will need to handle the weak entity type. Now, these attributes, these means the primary key attributes of the identifying relationship, okay, and the so will in fact also be a foreign key in R prime referring to the table corresponding to the owner entity. The owner entity has been mapped to a table, and so now these primary key attributes of that particular that we have included into the table of R prime will be the foreign key in R prime referring to the table corresponding to E. We will see some examples and then it will become clear. And what should be the key of R prime? Key of R prime is the partial key of E prime plus the key of the owner entity. The key of owner entity has anyway been included into this table, and so that set of attributes plus the partial key together would be the key for R prime, the table R prime. And then multi-valued attributes have to be dealt separately, as we will see a little later. Okay. Now, let us look at an example to clarify this situation. We had this kind of a example in our earlier discussion. So, section is a weak entity owned by course, okay, and the identifying relationship is this has section, and partial key is section number. Okay. So, let us assume that the course has been already mapped to a table like this: course ID, name, credits. Okay. So, it is a strong entity, and so we will map it directly into a table with these attributes, and then the whatever is the key for the entity will become the key attribute for the table also. Now, this is a weak entity and it is owned by a strong entity, and so all these attributes will come, but then the primary key of the owner entity also is added as an attribute. And in case that owner entity is itself is a weak entity, as I was pointing it out in the previous slide, then we will first map that into a table, in which case it will get the partial key of that plus the primary key of its owner entity as the key. So, those two things together will now come to the table here. So, like that we will be able to capture the information. So, section number, course ID now together will be the key. So, course ID because it is the primary key of the owner, section number it is because it is the partial key of the weak entity. So, these two things together will be the key. So, we underline them, and now the course ID that we have introduced here, okay, borrowed from the owner entity, will obviously should be a foreign key referring to the courses. In general, the primary key attributes that we introduce from the owner will be the foreign key attributes that refer to the owner relation, whatever is the owner relation. Okay. So, I hope this, so let us go back to this slide. So, attributes of R prime are attributes of the weak entity plus the primary key attributes of the identifying strong entity, and in case that is a weak entity, the partial key of E plus the primary key of the owner of E will be the attributes, and these attributes will be a foreign key also in R prime referring to the table back, and so on. So, this should be clear now. Any questions in that? Now, let us talk about multi-valued attributes. Multi-valued attributes actually give rise to a special kind of a situation. Recall that in the relational data model, I have been emphasizing that a cell of a table in a particular row contains only atomic values. It cannot contain set of values or list of values or anything else. It contains only one value. So, these multi-valued attributes is, by its definition is a bunch of values, right. So, we cannot directly store it as a value in a cell of our any relational table because of the constraints that the relational model has. Okay. And so, what happens here is that we need to kind of introduce a separate table for each of the multi-valued attributes that the entity has. So, let us take just one example here. So, email ID. So, we will do this after the entities have been mapped into tables. So, right now student has already been mapped and it does not have the multi-valued attribute. So, it is without, so we that is why we did not mention about the multi-valued attribute when we are mapping. We said they will be dealt with separately. So, now take up this multi-valued attribute, create a separate relation for that, whatever be the, so you will have to invent the name for the relation, and then introduce this attribute name and then the primary key of the entity for which this is a multi-valued attribute, and then make them together as the key. So, you can see that why is this needed? You can see that since roll number, which kind of identifies the student, has association with multiple email IDs, we will have to repeat the roll number with all of those email IDs. That is the only way to capture a set of entity, a set of values associated with a particular entity, because this relational model has a constraint that this particular column can only have exactly one value. It cannot have list or set of values, right. So, roll number, email ID will obviously be the key together now, because unless both of them are kind of given, you can't identify the row in a tuple in this relation. Okay. So, it is also obvious that this roll number is referring to the student entity, and so it will be a foreign key referring to the corresponding entity, I mean the table corresponding to that entity. Okay. So, one column for each of this, one column for this attribute. What is that attribute? That attribute is this multi-valued attribute. So, one column for that, and then the columns for the primary key attributes. So, in general this primary key, there could be multiple attributes in the primary key. So, one column for each of those multiple corresponding to the either the entity type or the relationship type for which we have this as the multi-valued attribute. Recall that even relationships can have attributes and they can also be multi-valued in the case of ER model. And so, when we deal with multi-valued attributes, we would have already mapped that relationship type into a table. Okay. And so, we take the key attributes of that table and then include them here. Okay. So, that is how we have to deal with multi-valued attributes. Okay. So, moving on, let us see how we can, so far we have focused on entities. Let us see how to handle relationships in the ER model. Let us first take up this binary one-to-one kind of relationship. So, one-to-one relationship, as you can recall, involves it's binary. So, there are two entities. So, S and T, let them be the entities that are in relationship R, and let us say we have already mapped S into S prime, T to T prime, right. So, we did the mapping of the entities, and so we have got two tables, and now we have to handle this relationship. One approach to handle this relationship is the kind of a simple interesting approach, where we kind of introduce what is called a what can be probably called as a lookup table. Okay. So, which will basically just have two attributes when whatever is the number of attributes, basically contain the key of S prime and key of T prime together. That is all. That is one approach. We will see that. Actually, I will come back to that a little later, but let us see how we can handle the specific case of one-to-one relationships. Let us say choose an entity which has a total participation in R. One of them is likely to have a total participation. Let us say if there is one, let us say S has a total participation. Then in this case, what we can actually do is to include the primary key of T prime, the other relation, as a foreign key in S prime, referring to the relation or the table T prime. And in case this relationship type itself has some attributes, then map all those simple attributes or simple components of those composite attributes as attributes of S prime. Okay, this is one approach. I will show you an example, and then it will become clear as to what we are exactly doing. So, we give preference to the one that has total participation, and we basically change the relation scheme of that particular thing by including the primary key of the other as a foreign key here. Okay. In this case, we can in some sense do the other way around also, but I will show you with an example. Okay. So, let us look at this student entity, hostel room entity, okay, and student is identified by roll numbers, and hostel room, for a moment let us assume that hostel rooms are identified by room number. Room number is the key for hostels, let us say. Okay. We will make a specific assumption here. We want basically two entities with their keys. So, we have taken student and hostel room, and let us say it is a one-to-one relationship. That means every student is given a hostel room, okay, and yeah, the hostel room can only have one person, if at all. So, this is a partial, this is a total participation. That means every student is given a room, and this is partial. That means some hostel rooms could be unallotted. It is a luxury, of course, to have hostel rooms not allotted. Okay. So, let us say the S is the S is the student, R is that relationship, T is this one. So, what basically we have done here is that the student would have let us say student is actually mapped to student table, in which case we have roll number, name and home address as the 3 attributes. Only up to that will be the student entity, and the hostel room will be room number, hostel name, address, because these are the 3 attributes. Room number is the key, so we will write it here. Now, in order to take care of this, what we basically have done is to augment this side which has a total participation by basically adding one foreign key to take care of this relationship. One attribute that acts that is actually a foreign key referring to the other relation. So, basically we want to capture as to what is the student room to which this particular student is associated with. So, we augment the student and then introduce a new attribute room ID, and then since its value these values are going to be used to refer to the hostel room. So, we make it as a foreign key that refers to the hostel table. Okay. Now, you might say that why do not we do the other way around? Why do not we include the roll number in the hostel table and saying that this particular hostel room is assigned to so and so student. In this case, we could even do that. Recall it is a one-to-one relationship. So, there is exactly one student to which it has been assigned, and so you could actually augment the hostel table, right, the room, this table with a roll number as with roll number or student ID or whatever you can call that attribute, and then make that as a foreign key that refers to the student. Just like we did here, we can do it the other way around also. But only issue would be that since we have assumed that this is not it is a partial participation. So, there might be several rooms which are not allocated, in which case they will the value of roll number or student ID here would be null. In case it is not allocated, it will be null. If it is allocated, it will be the student ID of the corresponding name. So, there will be lot of null values if we choose the other relation which has partial participation. You would also go to another extreme and then so this foreign key name, whatever in general the foreign key name of course need not be the same as the primary key name, but it could be some other name, right. For example, I said here room ID, which is basically refers to room number. Now, we could go also to a little bit of a extreme approach in which we can merge these two relations together and then put them as one big relation. We could do that in this case because it's a one to one. There are exactly as many if it's a one to one, and then let us say both of them. So, both entities participate fully, say this is an important thing. If both entities participate fully, that means every hostel room is also participates here, saying that it is assigned to some student, no room is vacant. If that is the case, so if both entities participate fully, then we can basically merge these two relations and then get on a broad relation, a merged relation, which is a little I do not advise that, mainly because these entities have their own identity in some sense. So, we would like to capture them as separate relations, and then the association or the relationship is best captured using foreign keys rather than in some sense merging them, because they will not then logically make sense. So, as far as possible keep a relation to ensure that a relation is obtained from one entity. An entity is represented as one relation. Okay, so that is the approach that we can do. The other approach that I was referring to, like lookup table kind of approach, is that let this particular student relation be separate, roll number, name, home address. Let this be separate, room number, hostel name, address. We will create a third table in which we just capture the association only. What is the roll number? What is the room ID, associated room ID, that we can capture separately as a lookup table in some sense, alright. And then of course, in that relation you will have to make the room ID as a foreign key that refers to roll number, and the room ID, student ID as a foreign key that refers to roll number, and room ID as a foreign key that refers to the host roll number. So, you can have a third relation, leaving these two things as they are. But we don't normally advise that in the case of these one-to-one relationships, because you can manage the situation by augmenting one of these relation tables. Okay. So, now let us move on to how to handle a one-to-many relationship type. In this case, what we do, let us say S is a participating entity on the N side, one to many, right. So, there is a one side and an N side, and T is the other entity, let us say. And let us say we have already mapped S to S prime, T to T prime, corresponding, these are the corresponding tables. Now, what the approach here is, in order to handle this one to many relationship, is to kind of modify the N side table, the table corresponding to the N side entity, and include the primary key of the other as the foreign key here, and then include any simple attributes or simple components of the composite attributes of that relationship itself as attributes of S prime. So, basically we augment the scheme for S prime, which is the table corresponding to the N side entity. So, again this will become clear if we show an example. Let us say a professor guides many students. Let us say each professor guides many students, but each student is guided by exactly one professor. Each student is guided by exactly one professor, but a professor guides many students. Let us say that is the one to many relationship. And so, what we are now saying is that take the N side entity, that entity had, no sorry, the N side entity has come this side, the N side entity is here. Okay, the N side entity is student, so it has roll number and name. I just simplified the thing. I mean, it could have several other attributes, but for the illustration purpose, let us just have roll number and name. Now, this is the N side entity. So, augment this by introducing a new attribute and make that as a foreign key that refers to the other relation. What is the other relation? The other relation is the one side entity, which is professor. So, it has name, phone, professor ID. So, name, phone, prof ID. Now, basically what we have done is to, for each student, in each student row, we now introducing a new attribute called the guide of the student, which will be an employee ID that refers to the professor who is the guide of the student. So, notice that we cannot do the other way around here, because a professor guides many students, and so if you want to now augment this professor side table with a new attribute saying that whatever students guided, then that will be multiple values, and you cannot put multiple values into a cell, and that causes trouble. So, we actually solve the problem by augmenting the N side of the N side entity, I mean the table corresponding to the N side entity by appropriately introducing additional attributes. Okay. So, So, let's just reread this again if you want. So, let S be the participating entity on the n side and T the other side. So, include the primary key of T prime as a foreign key in S prime, that is what we are saying. And in case there are attributes for the relationship, include them also as additional attributes in S prime. So, in case there is an attribute called big in date or something like that, you basically make that as an attribute on the student side itself. Okay. So, that is about the two specialized relationships, one to one and one to many. Let us now look at the many to many relationship. Here there is actually no option to either augment the one side or the other side. So, now we basically have to go for a third relation. Okay. So, make a separate table T for this relationship R, okay, between entities E1 and E2. Okay. Let us say E1 and E2 are already mapped to R1 and R2, E1 is mapped to R1, E2 is mapped to R2. So, in order to handle this many to many relationship, now introduce a third table, where you basically include the primary key attributes of R1 and the primary key attributes of R2 as foreign keys. Okay. Because this is what basically captures the association. Okay. Here is one entity, here is another entity, these two entities are associated with each other. So, let us take that combination and then give a provision for expressing those combinations in some sense. Okay. Now, and of course, once we do that, this Fk1 will be the obviously the foreign key that refers to the primary key of R1, and Fk2 will be the foreign key that refers to the primary key of K2, and these two things together will be the key for the new table, in some sense the lookup table. Okay. Again an example will clarify the situation. Student enrolls for courses. So, course is an entity identified by the course ID, student is another entity, roll number is the key, and now this is a many to many relationship. Student enrolls for many courses and each course is enrolled by many students, right. That is why it is many to many relationship. And so, you cannot okay, basically let us say student is mapped to roll number name, course is mapped to course ID name. Okay. Now, in order to handle this, we have to necessarily go for a third relation, which basically captures what roll numbers are associated with what course IDs, and these things together for every course side. So, if you from a student side, if you see if he is doing 5 courses, then that roll number will get associated with those 5 courses and will get listed in the as tuples here. And if course ID one particular course is being done by 40 people, then all those 40 people along with that course ID will be there as tuples here. Okay. So, you basically have to realize that we cannot augment the student table with a course ID, because there are multiple courses that student is doing, and we cannot augment the course with a student ID, because there are multiple students doing the same course. So, we introduce a new relation, which is in some sense called the in some sense a cross reference kind of relation, or it can also be called as a lookup table kind of relation, which basically allows us to capture the association. And then in order to get more information about this we need to refer to the table. So, we make this as a foreign key. In order to get more details about the course, we have to refer to the course table, and so we make this as a foreign key. Okay. So, this is how we capture many to many relationship. So, you might, so since the other relationships like one to one and one to many are in some sense special cases of many to many, we could take this approach in order to handle the other cases also, but then no, for those cases, as we have argued earlier, there are better solutions where we can avoid having a third relation. Instead, we can simply go for a better solution where we either augment the one side or the n side. Okay. Now, as far as finally we have to handle these so called recursive relationships, where a course, I mean a particular entity is participating more than once in a relationship in appropriate kind of roles. So, but then this is if you think about it, it is not a major issue, because we basically can treat it as two different entities and then basically create foreign keys to refer to the same table more than once. Okay. So, let us look at this. So, is prerequisite of is a recursive relationship involving course in two roles, once as a course, once as a prerequisite. So, course itself has course ID, credits and some I do not know, timing should not be here actually. The department, offering department, you could take it as offering department. Course ID, credits, offering department, let us say. So, now in order to handle this, irrespective of whether it is many to many or otherwise, we basically create a new table and then create attributes corresponding to the role names, prerequisite and course, and then make both of them as foreign keys that refer to the entity that is involved. Okay. So, this is how all the major constructs in the relational model can be mapped, and the information can be mapped into the relation, all the major elements of the ER model can be handled, and then we can capture the information into the relational model. So, please practice this on those exercise problems that I have given. After drawing the ER model, try and translate that into a relational model using this systematic, some 6-7 steps are there here. So, using this approach you map it and then see how exactly it is coming out, so that you can also try and repair your model, relational model. Now, finally, one point is this approach of keeping a cross tab cross reference kind of a table can kind of generalizes to n-ary relationships. So, in case there is an n-ary relationship, then basically we can have this third table which captures this relationship will have one more attribute, which again will be a foreign key that refers to the primary key of the other. So, in general we can use this approach to capture the n-ary relationships in the ER model. Okay. So, like that we can capture all the details that are mentioned in the ER model. Okay. Any questions? So, for those exercise problems, please try out and map them into relational models, and then try and then see how exactly they are coming out. Okay. So, let us stop.